What's happening, dogs? Mr. Allen here, about to get triggy with it in this video. We're going to evaluate these 6 different trig functions using special right triangles. So you can do so using the unit circle or special right triangles. I'm going to show you guys the special right triangle method in this video. So cosine of 135. What's my reference? It's a 45-degree reference located in the second quadrant. So I'm going to draw that up right now. Draw up a triangle in the second quadrant. That'd be 1, 1, root 2. Make sure that we pop a negative on that one because it's going to the left. And we're looking at it from here, always from the origin. That's where your angle is always going to be when you're trying to figure this stuff out, okay? So cosine is adjacent, which is -1, over my hypotenuse, which is root 2. Now, in math world, we have to rationalize our denominator. I hate it. It's the worst. I think this is totally fine. But we still haven't agreed to all abandon ship on the rationalizing of the denominator. All right, so I got -1 times root 2, so that's negative root 2. Root 2 times root 2 is just positive 2. And as you see these, when you see like, oh, it's -1 over root 2, you're just going to know that it's negative root 2 over 2 because they always rationalize the exact same way, okay? But that's how you'd show it. For some of these other ones, I'm not going to show all those little steps, all right? Next one here. Let's go blue. I got tangent of 5 pi over 4. That is also a 45-degree reference, but it's located in the third quadrant for this one. So I'll draw my triangle, third quadrant. We got 1, 1, root 2. These are both going to be negative in that case. Still looking at it from here. That's a right angle right there. My hypotenuse is always positive, okay? Always positive. It's only the legs of the triangle that need to be addressed, whether they're negative or positive, okay? So tangent is opposite over adjacent, so -1 over -1, which is just positive 1. Woo! Also, fun fact, little maybe side note, if you will. I'm just going to pop it right here. I think you could probably see it, even though I have the Yo-Ro going on. ASTC. What does this mean? All of my trig functions are positive in the first quadrant. Sine and cosecant, it's reciprocal, right, are positive in the second quadrant, whereas tangent and cosine and their reciprocals are negative. Here, tangent and cotangent are positive, but the other 4 are negative. And here, cosine and secant, its reciprocal, are positive, whereas the other 4 are negative. That's what ASTC means. This checks out. Tangent was positive. Yay! Woo! This is super helpful when you're doing the unit circle method, but can be a great way to double check yourself before you wreck yourself using special right triangles. Okay? Secant, 210. That's a 30-degree reference here for this one, located in my third quadrant. So right down here. That's a 30-degree reference. I'm looking at it from there. So across from 30 is 1. Next to it, adjacent to it, is root 3. And then we got ourselves 2. So 1, root 3, 2. Does anything need to be negative here? Yes. The 1 and the root 3 both have to be negative. Okay? There we go. Beautiful. Excellent. So secant is hypotenuse over adjacent. Okay? You got SOHCAHTOA and you got CHOSHIKAO. Okay? I'm going to write that down right here too. So we got SOHCAHTOA. Everybody loves that one. But you have the reciprocals as well, which is CHO, SHA, KA. Huh? I know it doesn't roll off the tongue quite as nicely as SOHCAHTOA, but we can still make it work, you know? Cool? All right. So secant, as we said, was hypotenuse over adjacent. So we got 2 over negative root 3, which once rationalized, multiplied by root 3 over root 3, is going to be 2 root 3 over 3. It is negative, so there we go. There's my final answer. Sorry, my negative got kind of buried there, but there we go. Negative 2 root 3 over 3, final answer. Wonderful and fantastic. All right, next one over here. I'll go orange now. I'm going to run out of colors, though. All right, we got cotangent of 5 pi over 6. That's a 30-degree reference that's located in the second quadrant. So let's go ahead and draw that up. Second quadrant, 30-degree reference. Across from the 30 we know is 1. Next to it is root 3. And we got 2. This guy's got to be negative because it's going to the left. Again, we're looking at it from that angle right there. Always from the origin. Okay, it's never this guy out here. Cool? Awesome. And we're never drawing our sides back. They're always going back to the x-axis, never to the y-axis here. It's a little bow tie that it makes once you have all of them in there. Okay, if you were to have triangles in all 4 quadrants, you'd have a little bow tie. It's lovely. It's fantastic. All right, cotangent is the reciprocal of tangent, so it's adjacent over opposite, which means it's negative root 3 over 1, which is just negative root 3. Final answer. Yay! Not bad. All right. Next one here. We got neon yellowish. Okay. So we got 7 pi over 4. Over 4 is a 45-degree reference. A lot of people like to go back to degrees. It's more familiar, which is totally fine to do. I like it. I do it. Okay. Boom. All right, fourth quadrant. As it said, I don't know if I said fourth quadrant, but it is in the fourth quadrant. There we go. Woo. It's kind of a oddly shaped one. Not quite 45, 45, 90, but we'll work with it. All right, so we got 1, 1, and root 2 for my 45, 45, 90. Any of those need to be negative? Just this one right here. Okay, only that one, the root 2, the hypotenuse, the hypoteni are always positive. Okay, so cosecant is the reciprocal of sine, so it's hypotenuse over opposite. This guy right here. Lovely. Hypotenuse is root 2. Opposite is negative 1. So our final answer is negative root 2 for this one. Beautiful. And last but not least, I'm gonna go back to blue on this one. Okay. Actually, wait, I have a red one. I'm going to try this one out. No, purple. Purple. It's a different marker, okay? Different marker. Got 2 different types, okay? See which ones work best. All right, sine of 300 now. Okay, so 300 is a 60-degree reference angle. So I'm going to go ahead and draw out my triangle here. It's going to be located in the fourth quadrant, 60-degree reference. So 60, across from the 60 is your root 3. Next to it is 1, and this guy's 2. Do any of these need to be negative? Yes, and I didn't leave myself a whole lot of room there, but that's going to be a negative root 3. Okay? So we have our 60-degree reference. Across from that is going to be the root 3. Beautiful, fantastic. Sine is opposite over hypotenuse. This thing kind of rattles a bit. That's kind of annoying. I'm not going to use this one anymore. All right, so we get negative root 3 over positive 2. No rationalizing. No, nothing. That was straightforward on that one. It's pretty dope. I like it. Boom. There we go. So that is evaluating trig functions using special right triangles. The argument is that it takes a little longer to draw these things up. If you practice the unit circle, it takes a little longer to get used to the unit circle, but you can move really, really, really fast with the unit circle. And I totally agree with that with practice. However, I often see students retain this. Then when we come back to evaluating trig functions later on, they recall triangles and can piece it together a little bit easier if they're out of practice on evaluating trig functions. It's also super helpful when we are dealing with ones where we give you like triples, like the sine of theta is equal to 3 over 5, find tangent of theta. You got to draw triangles up anyways for that. So I like having the familiarity with triangles, but maybe I am partial because I'm a geometry teacher. I don't know. But there you go. This is one way of doing it. I'll show you guys unit circle in another video. You can make the choice because you know what? This is America. You get the freedom to choose, baby, which way you want to evaluate trig functions. The American dream. All right. See you later.